Good morning or good afternoon, everybody who joined. My name is Kwasi Mensah, and with me is Nimala. Nimala?
Hi.
Okay.
Hi, everyone.
Yeah. So today we're going to talk about spinning up and scaling up Java application, scaling out Java application. We really hope that you're going to ask a question. You know, the main purpose of this event or Ask Tom series, we were going to do it every month, is to be available. And so you can ask any question. We have to pick a theme for each session. So today's theme is performance and scalability. So we really hope you have some questions. And if you don't have, we have things we can share with you. So for a few minutes, I'm gonna listen, and we're gonna listen to you guys so you can unmute yourself and you can ask a question, and hopefully Nima and myself will be able to respond. So please speak up. Or you can use the chat if you would like. You don't want to speak, be discreet, you can use the chat. Okay, any question, anyone, any concern, any on scalability and performance for Java and Oracle database? Okay, I suppose question will come when we start sharing stuff. So we have things we want to share with you. And so the first is we're going to discuss a little bit of how to speed up Java applications with Oracle. And then we're going to talk about how to scale out Java workloads. Okay, so to speed up Java application, here are some best practices and recommendation. So the first thing is database connectivity. As you probably know, connecting to the database is very expensive. So the motivation, the recommendation is you must have a connection pool. You could use a client-side connection pool. We're calling it UCP. It stands for Universal Connection Pool. Or you may use a server-side connection pool called Database Resident Connection Pool, or DRCP in short. Nema, feel free to interject anytime if you want.
Sure, Kwasi.
Yes. So DRCP stands for Universal Database Resident Connection Pool, which is on the server side. It is useful if you have multiple web tiers and you want to share the same pool by all those mid-tiers. For example, if you have thousands of mid-tiers and each has like their own pool, like 5 or 10, if you multiply by 1,000, you end up with 10,000 or 20,000 connections to the database. So you really want to reduce that workload. So that's the main reason you want to use the RCP. Otherwise, you know, for the average workload, the universal connection pool is good enough. UCP is good. It has a lot of knobs, so you can size, you can set a lot of timeouts. We're not going to show you stuff here, but just so you know, UCP is our recommendation. And we have fine-tuned it. It's very performance, very, very fast. Okay, so that's the base connection pool. You must have a connection pool. I think that's obvious. Everybody's using a connection pool. The other mechanism we have to speed up database connection is the deprioritization of failed nodes. this is a new feature. The way it works is when you enable the feature, you specify a period of time. For example, you say, if there is a failed node, please do not attempt to connect to that node for the next 10 minutes or 30 minutes. It's up to you. The reason we provide this mechanism is if you have a list of nodes to connect to, let's say you have A, B, C. We're talking about a rack configuration here where you have multiple instances. And let's say B is down. If you don't set this new property, the net layer, the listener will attempt to connect to A. If A is busy, it's going to attempt B. B is busy, it's going to attempt C. That's called client-side load balancing. So during that period, if B is down, the listener have to wait for the timeout to kick in, which is a waste of your time. When you're waiting for a connection, you want to get the connection as quickly as possible. So if you set this new property, it will remove B from the list temporarily, for the duration of the period that you set. This way, we ping A. If A is too busy, we ping C. So B is out of the loop. But after the period of time, it's going to go back onto the list. So it's not a definitive thing. It lets you set a time where you can have time to do some maintenance, or that B is on the maintenance or on the reparation, so you can set that. The other thing is a lightweight connection health check. So what is the usefulness of this feature? By default, when you request a connection and we check out a connection from the pool, we check the health of that connection, by pinging the database through that connection, through the socket. So with this feature, you are telling the driver, please do not check the health of that connection. I am confident that within, the next 30 minutes, all my connections are healthy. So you're saving this ping to check the health. Of course, if the connection is, eventually invalid, you're gonna receive an exception when you try to use it. But you avoid the systematic check of the health of the connection. Anything you want to add, Nima?
Nothing, Kwasi. So I think we have 2 more people. So should we just pause and open it for questions until now before we continue?
Okay, hi for people who just joined. We wanted this to be conversational. So if you have any performance or scalability question you want to ask, we prefer to hear from you rather than us presenting. So you have anything, you can unmute yourself or you can use the chat room and ask the question. And so I'm posing the presentation to see if the new people who join have any question or any preoccupation they will want to discuss.
Yeah, this is Coy. I don't have anything right now. You can continue on for now.
Okay, thank you very much. Okay, so that was connection. Any question on the connectivity, database connectivity? Have you experienced any problem or concern regarding database connectivity with Oracle from Java? Okay. So we just covered the connectivity. Somebody wants to say something, I guess? No? No, okay, great. So we just talked a little bit about connectivity. The next expensive operation is the statement processing. So as you know, you get a connection, and then your Java code will ask, take the connection object, create the statement object, and then run some SQL statement, whether it's a query or insert, update, delete. So the question is, how do you process a SQL statement? And as most of you and everybody on the call probably know, you have to parse the statement. You have to bind if it's a query, or whether it's a DML or not, and you need to set the value of the bind variables, and then you need to execute. And if it's a query, you need to get the result set. So those are steps, and those steps, the parsing is very expensive. It's really, really expensive. So that's called hard parse. So you don't want to do that every time. So you parse the first time, and when you come back on the same statement, you don't want to parse it again. So that's why it is a best practice to always use prepared statements. Prepared statements are parsed once, and that's it. The subsequent execution, you use bind variables, and you avoid the parse option. Okay, so we always recommend. The other benefits of prepared statement is it avoids SQL injection. So nobody can trick your application and give you some dynamic SQL that you will execute, and it will harm your system. So that's the other benefit, security benefit. Okay, so prepared statement, they're mandatory. And then caching, statement caching. If you don't cache a statement, caching on the client side, at the driver level, we have an array of statements. So let's say the array is 20. The driver will keep the 20 most used or the 20 last used. I cannot remember exactly in which order it does it, but it will keep that in those arrays. So when you execute statement number 1, the first time it will send the text of the statement to the database. The next time you execute that, if it's cached in your array, of cached statements, it will just tell the database, oh, please execute statement number 1. I don't need to send you the text. You already have it. Because the database has all the SQL statement that it has been executing for the last period of time. There are a lot of libraries in the database where those statements are preserved. So you just tell the database, execute statement number 1 or number 2 or number 5, whatever. So that's the benefit of statement caching. And when you do that, you avoid what's called soft parsing, because it's parsed, okay, but you need to send the text, and the database will do a lexical analysis of the statement and then say, hey, I have it already, so I don't need to parse. So you avoid that. The other thing in terms of statement processing is the result set caching. So this is wonderful. You run your query, you get the result set for the first time, and then the driver will keep the result set in its memory. You also have the option of caching with change notification. This is a very neat feature. It's been around for a long time. It's called query change notification, which means I am using the result set, so I don't need to go back to the database. If I'm executing the same query, I will just get the result set from the driver's cache. But the benefit of change notification is if a change happens on the database which impacts the result set, let's say somebody makes an update or delete or insert into the tables, and then if you were to execute your query again, the result set will be different. So the database is smart enough. When you register a query, database is smart enough to find out, hey, somebody just makes an update or insert or delete, which changes that the result set of that query that somebody has registered with me. So I need to send a notification to the registration. You know, you can register, for example, the driver can register and receive the notification. A PLC call package can register and receive the notification. Anyway, there are mechanisms for registration and receiving the notification. So the database will send a notification, the driver will invalidate the result set, and will execute again the statement to get a fresh result set. So result set caching with change notification is a very good feature if you want to cache, for example, static tables, you know, tables that don't change so frequently, you know, like a price list or things like that. And you can share across all the threads within your JVM, you know, within the application. So that's a very useful functionality. Proxy result set caching. Okay, so I'm gonna be presenting in a few slides something we're calling connection manager in traffic director mode. Connection manager has been around for a while. Now we've extended it with some mechanism. So I will explain when I get to the slide, but for now, just retain the fact that the connection manager in traffic director mode is a proxy, it's a database proxy, which sits between the database and the application. So it's a middleman, and it can cache result set. Okay, so it caches the result set. So a lot of application, not just one JVM, multiple JVMs, can be sharing the same result set. And the last, in terms of, last topic, in terms of optimizing statement processing is array operation. So you can do an array fetch. So you fetch rows by array, by specifying number of rows to fetch for each interaction with the database. So those are network traffic optimization. And DML, array insert, array update, array delete. People also call them batch insert, batch update, batch delete. So those are all array operations or batch operations that optimize network traffic. So instead of sending each row, you buffer and you get them by chunk and you optimize. And anything you want to add, Nimala, to the optimizing statement processing?
Nothing, Kwasi. I think you have covered everything.
Okay, so people on the call, any question, any preoccupation in that space? Okay, no question. Okay, moving on. This is a picture of the database resident connection pool, and you can see here, this is the pool. On the database side, a DBA can start the pool, size the pool, stop the pool, whatever it does. On the applications, those are web tiers, you just specify that you want to use a pooled connection. There is a prefix, pooled. When the listener sees that, it knows that this is a DRCP connection. It will ask the connection broker, which is here, to give you a connection from the pool. So the broker gives you a connection and you have a direct attach to the connection. So you use that connection as if it was a dedicated connection you get from a client-side pool. So there is this handoff step, the the client makes a request, the listener sent to the broker find the connection in the pool, and then establish a direct connection with the client, a direct connection. So that's how it works. And you can see that because it's separated from the JVMs, it can be shared by multiple meteors, okay? We don't have time to go into the details, but if you can Google or search on our website, DRCP, you can see abundant literature about it. And at the end, I'll have a pointer to a white paper where you can see everything we're talking about. You can see some code fragments of how to do all sorts of things we're talking about here. Okay. So continuing with speeding up applications, optimizing the network traffic. We do have some features to help you in that space. The network data compression, and this is something we have introduced, I think in 12.1. I think it's been around for a while, but JDBC started to support this in 12.1. What it is you specify that you want to do compression on the database. The driver will compress data which it receives from the database. So it will compress the data, and depending on the possibility of compression, you can see a difference, significant difference, but it's more necessary in wide area network, not on local area network. The difference in local area network might not be that great, but in wide area network, maybe in cloud environment, it could be very important to set this property. The other thing you want to pay attention to that most people don't know about is the session data unit, or SDU. This is a buffer that the database, it is the size of the buffer that the database uses to send data to the client. So let's say you make a query, the database gets data from the table and put that in a buffer, a network buffer. The network buffer is shipped to the client, okay? So the SDU defines the size of the buffer, network buffer. So let's say you want to retrieve 10 megabytes of JSON document or XML document. By default, in previous releases, the maximum size of the SDU was 32K, and then I think in 12.1 it got bumped to 64K, and in 12.2 it's now up to 2 megabytes. So if I'm not mistaken on the releases. But so let's say you want to retrieve 10 megabytes. If you leave this to 64K, which is the default, let's say in 12.1, well, you're gonna need multiple interaction with the database to retrieve 10 meg. Whereas if you set it to 2 meg or 1 meg, you need 5 or 10 exchange with the database to recoup 10 megabytes. Okay, so it's very useful, but you need to be careful. It is per client, per connection. So if you have a lot of users on your database and they are all doing a lot of XML or JSON or large club blob operation, you probably want to set this to a conservative value. Otherwise, you're gonna blow the memory of the client machine because everybody will be allocated, allocating the 1 meg or the 2 meg of SDU. So it is important to be aware about it and be cautious about how you set it. The alternative to session data unit is called zero copy. So zero copy means it does with the database, we will not use an interim buffer. It will transfer directly from the table to the application, to the client. So those are features such as secure file lobs, introduced probably in 12 or perhaps a little bit before, but it's in 12.1 for sure. It's called secure file lobs so that you can look at it. It's good for large stuff. You can do deduplication, you can do compression. It has a lot of functionality. So look at this if you're in the business of processing large documents and you don't want to pay the price of copying into the network buffer before shipping to the client. So all those things happen under the cover and you need to be aware of it. The last thing I want to talk about in the network traffic optimization is session multiplexing. It means I have multiple clients connecting to the database, so each connection is discussed as a session. You know, you have a session on the database side. A session is executed within the database server process. So the session keeps everything you have, all your metadata, all your cursor, everything on the database side. So session multiplexing means we're gonna use one single network, okay, link, network, and then through that link, we will multiplex multiple connections, multiple sessions, so multiple connections to session on the database side. So it's an optimization of network attachment. So if I want to make an analogy, you channel, you know, multiple sockets through one physical network connection. So that's sort of to give you the mental idea of what it is. So it helps multiplexing. So the CMAN, not the new thing, but the old CMAN, the classic CMAN or connection manager, has been around for a long time and does that. So CMAN does two things, session multiplexing and security. You know, it has a lot of security functionalities, you know, denial of attack, keeping a white list, a black list, etc., etc. And by the way, the CMAN is used in the Oracle Cloud to make sure that a tenant will not access somebody else's database, for example. So it is a very important piece in the security area. It also does multiplexing. And now we have extended that with new feature. But I'll talk about it a little bit in the next slide also. So any question on network traffic optimization? Okay, you can ask a question through the chat. So myself or Nimala, who also on the call, we can take care of the chat while we're presenting. But we did not want to present, we wanted to talk. So it's okay. The last segment of speeding up Java applications with Oracle is what I call in-place processing. So in-place processing is a nice term to qualify Java stored procedures or PL/SQL stored procedures. So as you probably know, Oracle have been supporting PL/SQL since ages. I think probably version 6 or version 7. So it's been around for a long time. And then with the release 8i in 1990, I think, yes, 1990, we introduced Java, so Java VM built into the database. I mean, a database server can run Java, PL/SQL, SQL in the same memory space. So it's not like you load at runtime. It's built into, you know, when you install, when you enable it. So Java stored proc or PL/SQL stored proc, the beauty of those is you make one call and you process a lot of stuff on the database side. When I say a lot of stuff, I mean not just the SQL statements, but also procedural language, you know, like PL/SQL procedural language or Java. You can have Java SE, standard edition Java. So I mean plain Java, like think about the JDBC code that you plug into the database. So database execute everything on the server side and only return the results. So it saves a lot of traffic, and it is faster because you process data locally, no data shipping. So that's what I'm calling in-place processing. And it is a sort of trend in the architecture, in the market. Look at all the big data frameworks. What are they doing? They are putting the processing close to data. Data is distributed across multiple storages, whether it's HDFS or NoSQL or even Oracle. I mean, you can use Hadoop or Spark with Oracle now. So whether it's those, you put the processing close to the data. So it is not something coming from database vendors, but the other big data frameworks have also embraced that because they see this as a performance optimization. Now, people will say, oh, well, I don't like, Java or PL/SQL in my application. I don't want to break my application. Well, the problem is the market is also moving towards microservices. So you could have a microservice as Java, and you invoke that microservice from the other services from your Kubernetes or microservice framework. So it is still valid with the modern architecture. That's what I'm trying to say. Okay, so here's an example, a picture of Java in a database, and you can replace the same idea with PL/SQL if you are more familiar with PL/SQL. So one call to execute the entire procedure, which is here, the procedure is here. So it's Java with SQL statement. If your Java code in a database does not have SQL, it does not belong to here, to the database, unless it's doing something to enrich the database. For example, if you plug in a Soda for Java API, you can do fluent programming to manipulate JSON documents in the database. Or if you plug in, we have done it, but we have not published it, Hadoop code in the database, we can process Hadoop code, mapper or reducer directly in the database without, going out. And there are tons of examples of people plugging Java library in the database, whether it's Lucene to do search, to do indexing at the database level, etc., etc. I can talk to you for a whole day about Java in the database. It's my favorite topic. Okay, so what we're saying is you plug the Java code here and it's doing some SQL operation with some Java code around. And you can invoke from Java, from PHP, Node.js, C++, C#, Ruby, Python. Any client can invoke Java because it's wrapped as a PL/SQL procedure. So the implementation is hidden from the client. The client does not know it's calling Java. It's just calling a wrapper, a PL/SQL wrapper, and the wrapper itself invokes the Java. The wrapper is not a runtime. It's just a function wrapper, so no overhead. Okay, so it can be consumed on low network latency in wide area network or cloud environment because you only make one call over your network and you get everything executed. So that's the beauty of Java in database if you have the skill, or PL/SQL if you have the skill. And here is a picture of the connection manager in traffic director mode. As I said, this is the middleman. This is new. It's new with 18C. 18C is available for Exadata and the cloud. It's not yet available for on-premise on other platforms. So that's why we are not making a lot of noise about it, but it is there. So the traffic manager in the connection manager in traffic director mode is a new extension to the connection manager, also known as CMAN. So with the extension, we can transparently to application provide, we can hide the planned maintenance and unplanned outages to support zero application downtime. We can optimize session usage. That's what I was telling, that we can proxy result set. We can also do statement caching. The security is already part of the CMAN classic, so it's not new. Something we're looking into is when you're doing sharding, we can route the traffic to the right shard or right instance. But it also does load balancing of in rack environment. So all the key thing is the transparency to the application. So your application will connect to CMAN instead of connecting to the database. So you have to change the service definition in your tnsnames.aura, and that's it. So it is transparent to the application because you're not explicitly making any, there is no new API. You just change the the way you are connecting. If you're using TNS alias in your code, so you don't change your code. You just change the definition of the TNS alias. Okay. In coming weeks, we will make more noise about the traffic manager, the CMAN in traffic director mode, but I wanted to show you that this is also a mechanism that can help you in terms of speeding up your performance. And that was the speeding up, which is the performance part of the talk. The second part is about scalability. If you have question now, you can ask. Otherwise, Nima, do you want to talk about the scalability things? I can share, I can push the slide, or I can stop sharing and you can take over if you want. Either way, or I can present it up to you.
You can continue, Kwasi. I can add any comments if I have. Is that okay?
Okay, that's fine. So for our guests, do you have any question on the performance thing we have discussed so far?
So I just wanted to check if anybody is using Universal Connection Pool, which is our connection pool. You could either talk or type.
Okay.
Okay.
Let's move on. People will always, you can always interrupt us anytime. Okay, I will discuss the three things here, or four. So horizontal scaling of Java workload. So we'll talk about the new Java API for sharding. Then the shared pool for sharded database. And then we talk about the multi-tenant support for Java application. Also the asynchronous database access API, which is not available yet as a product, but it is an API that Oracle is leading and working with the community, with the Java community, to make it happen. And then maybe a little bit more about the CMAN in traffic director mode. Okay, so the idea is you traditionally have unsharded database, and Oracle has introduced sharding in 12.2, I believe, or 12.1, I cannot remember. Okay, so the idea is instead of having one big table or one gigantic table, you can split horizontally your table across multiple shards. So this is not new. Oracle is not the first. There are a lot of databases out there that support sharding. So we are coming to this plate now, and we have good support for it. So what do we have? I mean, from Java perspective, okay, this is a new API in Java 9. If you go to Java 9 and you check for Sharding API, you will see those are the APIs that Oracle has, I mean, worked with the community to make it a standard. So it's not anything proprietary. And the way it works is, let's say you want to connect to a shard database. You need to produce a sharding key. And if your application or your shards are also split by region, you need what is called a super sharding key. So super sharding key could be region, for example, EMEA, APAC, North America, or Latin America. Those are super sharding key. And then the sharding key could be a city or a state within the US, for example, California. It would be a sharding key, or a city, San Francisco, my preferred city. Sorry, just kidding. Okay, so the way it works is you need to set a value, and then you call, you create a sharding key builder. It's the same API here or here. And then you specify the value. This is a value, and this is the type of the data. And then you build the key. You use the build pattern. Okay, this is a Java 8 programmatic API, I mean fluent programming. Okay, so you build the super sharding key if you need one, but most of the time you will need to just build a single sharding key. By doing this, you specify, create the key builder, what is the value, and then invoke the build. After that, you just create a connection. You ask for a connection by giving the key you have created, or the super sharding key if needed, and invoke the build as well. So it's all about using the build pattern. Okay, so that's all you have to do in order to access a data which is on sharded database. Okay, so how does it work under the cover? Under the cover, the Oracle database shards are just things, regular databases, but we have something called the shard director. The shard director knows the topology of the sharding keys across all the sharded databases. So for example, this database here has shards 1 to 10. I mean, sharding key 1 to 10. This one, 11 to 20, 21 to 30. So the shard director has this topology, has this mapping. So when you ask for a connection, it goes to the GSM listener. It will, hey, this is the value of the sharding key. Okay, I know where it is. So go here. And then the application will go to that one. The driver will go here. Okay, so that's how it works. But the problem is, if we do that every time, you're gonna pay the price of going to the shard director every time. So that's not a good idea. So what we've done is, and this is what it looks like, we keep the shard topology is the lower key and the higher key for each chunk. A shard is a series of chunks, So the chunks have a lower key and higher key. Okay, so the user asks, and then you get the key, you go to the shard. Okay, so in order to amortize the cost and avoid going systematically to the shard director, we mean Oracle, the Universal Connection Pool, is capable of learning the topology. So the first time you request a connection, it goes to the shard director because we have no idea. It's blank. By default, we don't know. We don't have any topology. So we go to the shard director. It says, go here. And then we took the opportunity to dump the topology of the shard into the UCP. You can see here, UCP will say, okay, shard key 1 to 10 belongs to chunk 1 in shard 1. Okay, it does the same thing for the others. Every time you access a shard for the first time, we dump the topology. So you see, okay, at this time, UCP has the entire topology, the same thing that the shard director has. So, which means in the next request, UCP will just tell directly where to go without going to the shard director. So that's why we say UCP acting as a shard director. The benefit of this is, first, you don't pay the price performance, and the second is high availability. Even if the shard director is dead, I mean, it's down, UCP can continue to work. So we don't care. Remember, those are just regular databases, but your data is split across them through shard. Okay, so that's how UCP can learn about topology and act as shard director. So do you have any question on sharding key, the way UCP works, etc., etc.? Any question? Or Nima, feel free to add more if you want. Okay,
Okay.
no question. Okay, so moving on to multi-tenant. So this is multi-tenant, as everybody knows. The way it works is you have a container database, and then you have the pluggable databases. Okay, in the Oracle literature, it is one database instance capable of managing multiple databases, right? So multiple physical databases. Those are pluggable databases, okay? And the CDB is just a database which only has metadata, no user data. And so one instance will manage all this set. So multi-tenant has a lot of functionalities, and we are not going to cover those today. Okay, what we want to stress is from the Java developer perspective, instead of having a pool per PDB, you know, we call PDB pluggable database, you know, so here, for example, instead of having one pool for each of them, the solution we have is we have a shared pool. A shared pool for all the PDBs. Okay, so how does it work? You have the connection pool, which is a universal connection pool on the client side, and we have the shards. I mean, the PDBs, sorry. The PDBs are here, okay, and you can see that those connections are attached to PDB1, and those three are attached to PDB2. They might be idle or they might be busy, but physically they are attached to some database, you know, some pluggable database. Okay, so let's say PDB, a customer wants a connection to PDB3, a tenant. Well, we're gonna repurpose one idle connection here because it's not doing anything. We use a new service at the database level. You know, I think, I cannot remember, it's a set service, it's a new command under the cover. So UCP will use it under cover, repurpose that connection for here, and then the user will use it. So that's how we can share one single pool across all the PDBs. And you can do this by using a single data source with multiple services, or you can use one data source per service or per tenant. We document this in our literature. It's for time's sake, I don't have time to go into the details, but we have code fragment, etc., etc. We have 11 minutes away of the top of the hour, I mean, to end this event. Okay, a Synchronous Database API. I'll just give you a summary. It is a standard API we are proposing, and the goal here is scalability. You know, it's scalability because most of the time when you are accessing database using synchronous APIs such as JDBC, If you have 1,000 connections to the database and you're doing operations, all those connections are blocked. They wait for the database to respond before they go back to the end user. So what if we delegate database operations to another set of threads, and they are always busy because they're doing all the database operations, and the user thread return immediately. The user thread posts the work. Let's say, if I want to speak at high level, I would say the user thread posts database operation in a queue and returns. Another group of threads that implementation provide will pick up the work operation, the task, complete the task, and depending on what you have specified, if you look at completion stage in Java 8 or Java 8 comes with a nice feature called the completion feature and completion stage, completed feature, completed stage. So a work done by this database thread always complete. It complete normally or it complete abnormally. That means exception. Anyway, it is a task composition and it allows you to do asynchronous work, reactive programming. So you can schedule some task, do this, do that, and depending on the result, do this or do that. So you will have to change the way you code your application because it's no longer a procedural sequential. So you can do multiple operations. You can access multiple databases simultaneously, or you can have one database operation, you fire one database operation. On the other side, you get some data from some JSON or some JavaScript or whatever, and you get some images from some other place, and you compose all those to create your web page, for example. So the user thread is not sitting there idle, it's doing something else. And when the database operation completes, maybe it goes back to the user thread, or maybe it continue to some other thread. Maybe you fire and forget, okay? So that will provide a lot of scalability, and this is our strong belief. If you go here on this blog, we provide more details, including the Java 1 presentation, and also the mailing list where you can see the community discussion about the API. And you can ask questions on the mailing list, and our architect will respond. So we're expecting that with this we'll make, I don't know the schedule, but we hope it's going to become a new Java standard. It's not JDBC. It's not an extension of JDBC. It's a completely new API. And there are async APIs, but those are proprietary. So this will be a standard. Oracle is driving it, but it won't be an Oracle proprietary mechanism. So that's one more scalability feature to consider. Okay, I mean, that's what I have. We have this white paper that you can look at. We have this. So 18C is in reality 12.202, it's a naming gimmick. So when we say what is new in 12.2 release 2, most of the stuff are already in 12.2 release 2, the .1.01. The 18C is the 12.202. So we have few features, but it's not like a completely brand new releases. I'm saying that to you so you understand that those white papers are not obsolete. They also have a bunch of features which are in 18C. So we have our cloud paper, our what's new paper, and we have this white paper for performance scalability, etc., etc. So that's all we have to share with you, but we would really want to hear from you guys. So if you have any question on everything we have discussed, please speak up now. Nimara, anything you want to add?
Nothing, Kwasi. I think I'm good.
We still have 6 minutes. If you people want to ask anything on the chat, this is the time. Okay, we assume that you are satisfied with what we shared with you. We're gonna have another session next month on high availability. Anything you want to hear or you want to ask about high availability, I think, Nima, it's April 14, I guess.
Yes. It is April 14th.
Okay. So any last minute question before we close the call? Okay, remember, Ask Tom is an initiative that we want to go closer to the developers, and we will run the event every month, and we hope people will join and ask questions, and we will use the opportunity to share some information with you. So thank you very much, and have a good day. Bye.